gonna share my screen, and you can watch this recording. Okay, so the first thing you'll want to do, I mean, your answer is correct for number one.
Yeah.
Actually, I'm trying
One.
to understand your work here. Hold on, let me just go through all these questions. Okay. Yeah, no, you definitely have some errors with 4 and 5 for sure. Okay.
Yeah.
So at its core, any equation, your goal is to get x by itself.
Yeah.
So if we think about what's going on, I'm going to really kind of like be a little long-winded here, but I think it'll be good because to really help you understand what's happening. So that's like saying 9 times x equals 9.
Hmm.
So think like this. It's like 9 times blank equals 9. Now, if you do a little trial and error, which is you never do in algebra, but if you did, yeah, that makes sense, right? 9 times 1 times 1 is
Yeah.
9, right? We get it. But the thing is that our goal is to get x or get the blank by itself. So if I'm multiplying all these blanks by 9, I probably should divide by 9, right? That's the opposite of multiplication is division. We know this, right? So by doing that, these cancel.
Yeah.
So you have blank blank, or I'll just say x squared in this case. I'll bring it back to x squared equals 1. So basically what you're saying is that a number times itself equals 1.
Yeah.
Now, if you're squaring, the opposite of squaring is square rooting. And of course, square root of 1 is 1. But because you're square rooting, you got to put plus or minus.
Yeah. I just need to know how to root method. That's the one method I really need to know.
Right. And you just square root. That's what you
That's the
want
one
to do.
thing we need to practice today, because that's the one thing that's really gonna be on the test.
Right. So let's try it again. Let's look at number 2.
Yeah.
So now what do you have on the left side? Just x and x, right?
Yeah.
Or blank times blank equals 1/4.
Uh-huh.
So really what you're trying to do is you're trying to find two identical numbers that multiply to 1/4. Well, if you
So
think about it, x is probably gonna have to be a fraction, right?
so
A
it'd be
fraction times. So what fraction do you think that would be?
0.5 over
Yeah,
8.
exactly. 1/2. Now, the way you could show your work algebraically is this. Plus or minus 1/2.
Yeah.
And that's it. That's your answer. Plus or minus 1/2. Because when you square root 1, you get 1. Square root 4, you get 2. And you got to put plus or minus. Now, for number 3, you do a couple ways. You could move the 64x to the other side. And then divide, by x. But usually I don't want to do that because you lose a solution. So I'm going to do is I'm going to factor. That's the best bet. That's our best bet.
Oh.
What can you factor out of here?
Factor 4 and 16, 8 and
No, no. What do they have in common? 4x cubed and negative 64x.
4.
4 and x and x.
Yeah.
Okay, when you do that, that becomes x squared
Yeah.
and negative 16. Okay. And we continue breaking it down even more.
Uh-huh. Mhm.
And each of those, you want to set each of those equal to 0, or what makes each of those 0?
Yeah.
Because the whole thing has to be 0. Because we're calling the 0 product property. So we didn't really root anything here. What we did was we solved by factoring. Because if you have a bunch of factors, if one of those factors is 0, the whole thing is 0, right?
Yeah.
So that's what happens there.
We also need to find zeros. We need to find like zeros.
What was that, sorry?
We need to find like 3 zeros for problem number 3,
Yeah,
apparently.
exactly right. They're 3x-intercepts or 3 numbers that make the whole thing 0. Exactly. Okay. Now here, okay, so you made a crucial, well, actually definitely made a crucial step for number 5. You square 4x and 3 separately.
Yeah.
And you're an Algebra 1 student. It's understandable you're gonna make those mistakes. But we have to work on getting a better foundation, because
Uh,
foundationally this is incredibly flawed. Here's why it's incredibly flawed. Let me ask you this question. This should be a pretty simple one. If you were to work this out, what would you say the answer is?
25.
Great. Tell me what you did. How did you know? You do.
Oh, you do
I like
inside
it.
the brackets first, you do 2 plus 3 is 5, then
Yes.
square, yep.
Yes. Good. So you're being PEMDAS. Perfect. If there's a letter inside, it's no different.
Yeah.
It's the same thing.
Mhm.
But what you did was you squared the 4x and 3 6. You cannot do that. See, like here, 2 squared plus 3 squared is 4 plus 9, 13. No good. That's not what we want, right? We
Eh,
don't want that. So what we're gonna do is unfortunately, I'm not saying unfortunately, but you could do 4x plus 3 times 4x plus 3,
Yeah.
because that is what it is, and then do a process called FOIL, first outside, inside, last, or you can square root. If you square root, you get that. And then you just solve for x.
Mhm.
Move the 3 over, and it's two different answers. 4x equals 2,
Mhm.
or 4x equals -8.
Mhm.
So x equals 1/2,
Mhm.
or x equals -2.
Yeah.
And yeah, that's it. Those are your two answers. So you
Yeah.
do the same thing from before, just square root.
Yeah. Huh?
2x plus 1 equals, we got to put plus or minus 1. So -1 plus 1, which is -2, or 0.
Huh?
Yeah, and that's all you got to do.
All right.
So that should be hopefully pretty
Straightforward.
straightforward. Yeah. Yeah. So now,
I just need to learn how to do a T table,
yeah,
because that's
easy. So you do x and y, one column's x, one column's y.
Mhm.
Usually I'll plug in 0, 1, and -1.
Mhm.
Not all the time. So actually, let me backtrack a little bit here. You want to find the vertex first, because the
Yeah.
vertex kind of sets a tone for everything, because it's the middle, right? It's the foundation of the graph
Yeah.
of a problem. To find the vertex, there's a formula that we use called -b/2a.
All right.
Okay.
Huh?
So, and generally speaking, ax squared plus bx plus c is the standard form.
Yeah.
So your b is 0, because there's no x.
Yeah.
Your a is 1. So x is 0.
Uh-huh.
Now, if you plug 0 back into the equation, so that's the vertex. And then we choose numbers close to the vertex. We slowly branch out from it. Some to the
Yeah.
left, some to the right. So like 1 or 2 or to the
Uh-huh.
right. -1 and -2 are to the left. And usually 5 points is a good idea. And usually your Alex assignments ask for 5 points.
Yeah,
I
we
think
need to do 5 points.
what was that?
We need to do 5 points for the
Yeah,
test.
I personally, I think it's a bit overkill. I think 3 is sufficient as long as you have the vertex and 1 on
Mhm.
the side of the vertex. But 5 is just safe. So you get -3 and 0,
Yeah.
-3 and 0.
Mhm.
And you're guaranteed all the symmetry, right?
Yeah. So let's do a couple of these problems. I think I could just get better at them. So
100% you will. I know you will.
yeah. But
Okay.
can I use if we're finished with the problem, can I use the bathroom real quick?
Well, sure, yeah, I'll be right here. Just do what you gotta do. Okay. Yeah, so you do x equals negative b over 2a.
Mhm. And there would be
So y equals 4 minus 8 plus 6,
yeah.
which is 2.
Hmm.
And you choose some values to the left and to the right. Like I'll choose, oh, I'm sorry. Put in the wrong place. Negative 2 comma 2, my bad. Here we
Uh-huh.
go. So let's do like negative 1 and 0, and negative 3 and negative 4. If I plug in negative 1,
Yeah.
I should get 2. No, 3. Plug in 0, I should get 6.
Hmm.
Plug in negative 3,
You get 4
I should
or
get 3.
3, I mean,
And
yeah.
negative 4, I should get 6. Because these should be identical to the other two because they're symmetrical.
Uh-huh.
That's the whole point. So I'm being very intentional about that. And that's it. There's a graph. So when asked what axis symmetry at AOS, it's always going to be x equals the vertex, or x equals 0, or the x coordinate of the vertex, x equals negative 2. Intercepts, if it has any, or sorry, y-intercepts, yeah, that's when you plug in 0 for x. And the zeros if it crosses the x-axis, which we had it here,
Yeah.
but obviously this doesn't. So you don't have to worry about it for number 7.
Hmm.
Yeah, it's more of the same stuff. Well, now sometimes, like, I mean, this is also pretty easy too. Like, there's no b value, so the x coordinate of the vertex, if you do negative b over 2a
Hmm.
to 0,
Yeah.
plug in 0, you get 3. Plug in 1 and negative 1. I think that should be enough.
Hmm.
Now here, you can approach this a little differently. So h is 1
Hmm.
and k is 0.
Hmm.
And then so you have to compare, like, okay, you realize, okay, what's in h's position? 1, what's in k's position? 0, because there's nothing on the outside of the parentheses, but on the inside, x minus 1, x minus h. So you do a comparison.
Yeah.
So 1 comma 0, then you make a table. Um, Again, I'm getting a little lazy. I'll just do 1 point on each side. If I plug in 2, I get 4.
Yeah.
Plug in 0, I also get 4. Okay. So same thing here, negative 2, negative 8.
Uh-huh.
Again, choose numbers on each side.
Uh-huh.
Plug in negative 1, I get negative 7, or negative 7. I get that.
Hmm.
So if you see it written like this, where it's a parentheses, something squared plus something on the outside, you can use the vertex form to just compare.
Yeah.
If it's written like this, then you do negative b over 2a. So you have to be mindful of like what technique we're going to use to graph this. Sometimes you could factor them. I mean, sometimes that is possible too. That's yet another technique. If you could factor it,
Mhm.
then what we want to do is like, okay, so, what makes each of these factors zero, or what are my x-intercepts? So there is some fluidity, if that makes sense, of like, or different techniques you can use. And then you have to go in between those two, which is -3.
Yeah.
But I could also then done negative b over 2a and still get -3, same thing. And then if I plug in -3, I should get -4.
Uh-huh.
And there we go.
Yeah.
So yeah. And so that kind of does, is sufficient because the x-intercepts already counts 2 points. Find the point in the middle, which is the vertex, and then plug the x coordinate of the vertex into the equation, get the y coordinate that goes with it. That's enough. You're fine.
Yeah.
Um, yeah. So more of the same stuff here. Um, you can factor or do negative b over 2a. It's kind of but not all of them are factorable. So some negative b over 2a is always gonna be reliable.
Yeah.
But if it's not written in standard form, if it's written with like a parentheses squared, you can expand it if you want and do negative b over 2a, but that's a lot of extra work. It's better
Uh-huh.
just to utilize the vertex form.
Yeah.
Here, let's talk about solving, and we'll do some extra practice.
Uh-huh.
So complaining the square, the way that works. So we're gonna replace y with 0. And then you're gonna take half of b and square it.
Uh-huh.
So 16.
Uh-huh.
And
Yeah.
then you do what we did earlier, square root both sides.
Uh-huh.
Your teachers were kind of working towards that
Yeah.
process. So x minus 6,
Mm-hmm.
and then add 6 to both sides.
Yeah.
So it's 10 or 2.
Uh-huh.
You want to go halfway in between, which is 6.
Yeah.
That's your axis of symmetry.
Yeah.
Plug it in, 20.
Huh?
It's really low. So there we
Yeah.
go.
Uh-huh.
Um,
So could we do a little more of these problems, like
yeah,
15? I
yeah,
think
totally. 15
3.
quad form. In this case, what you do is you do x equals. Are you be given the quadratic formula, or do you have to memorize it?
I could write down my notes.
Okay, then I would. Yeah, so your A is 3,
Uh-huh.
your B is 5, and your C is -12.
Mhm.
So it's -5 plus or
Mhm.
minus square root.
Yeah.
Um, we have 169.
Hmm.
So 8/6, -18/6.
Yeah.
So 4/3 or -3. I'm just tripping. So there we go.
Hmm.
And then you just go halfway between them. Actually, I mean, we don't have to graph it. It's fine. I mean, you're solving it. But because the answers came out nice and clean, because the
Hmm.
inside of the radical was a perfect square. Um, are you allowed to use a calculator, by the way?
Yeah.
Yeah, okay, that's good. Yeah, but because that came as a perfect square inside the radical, then that tells me that this was factorable. Like we could have
Hmm.
factored if we so desired to do so. Yeah.
Uh-huh.
So anyway, um, that was an option. Um, something to just think about. Um, okay. We're gonna clear that.
Yep.
Okay, so I mean, we kind of covered most of it. I mean, I think we skipped a problem or two here or there, but now I think it's time for you to do some practice. So let me locate something here.
Okay.
Hold on. What about quadratics here? I mean, we could probably try these here.
Hmm.
It's not quite what we saw in your worksheet, so let's look at my Algebra 2 folder. It might be a little better. Hmm, Let me look this up.
Hmm. So after the session, how should I like study it? Because I think that's definitely the thing I need to study. If
Worksheets. I'll send. Hold on. Solve.
'cause I have no homework today, really. So I'm literally just me studying on it.
Here we go. Okay. It's too easy. I mean, it's still good, but
Yeah.
Yeah, I might have to mix them up because, well,
Right.
come
Sounds
on. Actually, I think I got it better. All right, this could work. Okay, yeah, this is what I'm talking about. Okay, we'll see these problems here.
right.
All right.
All right.
So what
So,
do I do?
well, so first of all, you need to yeah, so basically for this one, and what form are we using?
Well, we want square root, but first you have to get x by itself.
Yes, so you would do 6 divided by 6 or 6 divided by itself to get x isolated.
So that would be 25.
Yeah.
Then,
And then you have to do on the other side because where we're doing the first side, you have to do on the other side.
yeah, then you square root, which is what?
Oh, 25 times 25, right?
No, square root.
Oh,
What two numbers multiply 25?
5 and 5.
Right, but you do plus minus,
All right.
right? So go to try this one on your own. You'll need a calculator.
All right, let me on my
Actually, that one's
calculator.
kind of weird.
Is only as good as your.
Okay. So you want me to do 10, right?
Oh yeah. Mhm.
Be like positive -8, or did I punch it in wrong?
Yeah, so you divide negative 213 by negative 3. What do you get when you divide that?
That's by -3, right? You get -71, so plus -71.
So 71 and the x equals plus minus root 71.
Yeah.
Right. Okay.
Hmm. How would I do this one?
Again, your goal is to get so you have x times x over 25
Mhm.
minus 6 equals negative 2. So what you want to do is you want to move the 6 over to the other side.
Yeah. So You would make it a +6. Right?
Add 6. Yep. So you add 6 to both sides.
Yeah.
And then right now you're dividing by 25, so you have to do the opposite divide by 25.
Which is divide, which is multiply.
Multiply, so you get 100. And then square root.
So it's plus -10.
Plus minus 10, right?
Negative
Yep.
10.
Yep. Okay. So again, your goal is to just, to slowly, whatever's next to X, you slowly start removing it, putting it to the side, and then all's good. So here,
Mhm.
I probably should add 5 first.
Yeah.
Divide by 2.
So that would be 2 and then -6. No, I
And then square
know.
root.
So plus
And then subtract 2.
2 and
This was
then
a little messy because it didn't come out nice and clean. But, it's still the same process.
Yep.
Like you're trying to just slowly move other stuff to the other side.
Yep.
Let's take a look at 14. I know 14 comes out clean.
So hold on. So you would do it and then I'm pretty hold on, let me punch in my calculator.
Yeah, so what's the first thing we should do?
Should get 7 isolated.
No, you want to get X isolated.
Yeah,
So so right now, what should I move over? Like what would be the easiest thing to move over to the other side?
10.
No. From the left side to the right side. Because X is on the left side. You have to get X by itself on the left side.
7.
No, I wouldn't do that because
-4.
no, stop. Okay, I wouldn't move that 7 over because if you do, how are you going to move it over? You have to divide, but then you have to divide the 18 by 7 also. And that makes it more
Oh, so
complicated.
then do the 18.
Yeah, let's move the 18. And what's the opposite of subtracting 18?
Oh, multiply.
Opposite of subtracting.
Yeah,
What's the
multiply.
opposite of
No,
subtracting?
multiply addition.
Right. So you add 18 to both sides.
Mhm.
So now you got this. Okay, now we gotta get rid of that 7. How do I get rid of that 7?
You would -7. So it would be 2, 6. Right? The answer or no?
So you divide by 7. So when you divide by 7, what do you get after you divide by 7?
Oh, you divide by that's 2. X equals 2.
Well, hold on. So divide by 7.
Yeah. Might be
So what's 28 divided by 7?
set 4.
4.
Yeah.
Then you'll square root
That's 2.
plus or minus 2.
2, yeah. And then that's it. Or
And then move it over 4 plus 2, 4 minus 2.
it's 6.
So 6 or 2.
Yep.
Right, exactly. 100%. Correct. Okay.
Hmm?
I think we could now maybe try graphing again.
All right.
Like number 10, for example.
Yeah.
So I'm gonna have you make the t table and plot the points. So I kind
So
of do this up for you.
Either
we
move
can
to
do another
0,
equation.
1, or no. Your points are
Negative 2, you'll plug -2 into the equation, get the y coordinate. Then you want to plug in values to the right and then to the left.
So for 0, we can do 4.
I'm sorry, repeat that.
For 0, we could do 4.
No, you plug into this equation. So, well, actually, start by plugging -2 in. So you might want to use a calculator.
I'm
Start
on
by
the
plugging -2 in for x.
for both x's or just the one on the left.
Well, you know we're working on number 10, right?
Yeah, no.
Yeah, exactly. So plug in -2 into this equation here.
-2 squared,
Right.
-4. No, it's +4. Hold on. It's 4, yep. 4 plus 4x minus 5, so 4. So it's
So 4
3.
minus 8 minus 5.
3.
Oh, thanks. So it's -9.
Yeah.
Okay, let's do more.
And then so x equals -1, so it'll be +1 plus 4, which is plus minus 5.
So you have 1 minus 4 minus 5, which is what?
Hold on, 1.
-8.
8. Then 0, that would be 0, which would be -5.
Right.
Then for -3, it would be -3 squared, +9, plus 4 minus 5. So that would be 8.
-8.
And then 4 squared, it's 16. 16 plus 4 is 20 minus 5 is 15.
Slow down.
Oh,
It should be the same thing as 0.
oh, so it's -8.
So if you plug in -4, you get 16 minus 16 minus 5 is -5, right? Okay. So I mean, it's hard for me to plot it, but I didn't really do a good job of.
Mm-hmm.
So yeah,
Yep. That makes it way like the second time I did like this last time I did like each problem, it's way easier and like
Mhm.
I should understand it.
So let's try to make a couple more when I recall.
All right.
So number 4.
Mhm.
So again, let's do x equals -b over 2a. What's b in this problem?
For X.
But there's no x. So we assume b is what?
0.
Right. So 0 over 2 times 3
Uh-huh.
is 0. Okay. So then we have 0, comma 2. Plug 1 in, you get 5.
Mm.
Plug that one, you still get 5. And then you just plot those points and you're good.
All right.
So that's what you really want to aim to do, is like kind of do the -b over 2a thing often. So I think what would make the most sense to help you for today. I'm really surprised I didn't see when I said solve. Here, solve a quadratic equation by square rooting. Okay, don't know how to spell. Okay. I think this link is good. Let me email you that link. I like this link actually.
All right.
We saw that one. It's too easy. Actually, that might work.
Uh-huh.
Only thing is, they don't have the answers though. Okay, let's see. I like this one too. Okay, good. These have the answers.
Alright.
Yeah, I
Mhm.
like this. Okay, this is it. This is the one.
Huh? Sounds good. All right.
I think you're. Mm, Yeah, that's a good one too. Okay. All right, I think you got plenty that you can work on, and I'll send the video when it downloads.
Sounds
And I
good.
think we're aiming to meet again tomorrow, but I can't do 5. Can you do 6?
Uh, yeah, that works.
Okay. All right. I'll text your mom. All
Okay.
right.
See you. Bye.
Cool. I think we're good. See you later.